Hello and welcome back all. 2.8, the unit that never ends. Wrapper classes, integer and double. Here we go. Our first concept will be the wrapper class. Our learning objective for wrapper classes: create integer objects, call integer methods, create double objects, call double methods. Were you ever all set and ready to leave the house when someone told you that you can't go outside dressed like that because it's too cold outside, and then they wrapped you up before they sent you out? Well, the same thing happens to primitive data types. There are some places that only objects are allowed to go. So sometimes a parameter will expect an object, and a primitive data type is not an object. What we have to do is wrap that primitive data type in an object, in this case of class integer, so that data is allowed to get where it needs to go. We've already been looking at some classes from the Java Lang package. We've previously looked at the string class and string methods. Now we're going to be looking at the integer class and the double class. This aligns with our essential knowledge. The integer class and double class are part of the Java Lang package. On the left side of the screen, you see a breakdown from the Java API regarding the integer class. We see some of the instance variables, we see max value, and we see min value. We should notice that those are labeled as static, which means that we reference them by class name instead of by object. We have two constructors from the integer class that we want to pay attention to. One where we can pass in an int, and it will make an integer object from that int. And then one where we can pass in a string, and it will make an integer object that represents the int value inside the string. We have one method that we are going to look at called int value, and it will return the value of that integer object as an int primitive data type. On the right-hand side of the screen, we see a breakdown of the double class from the Java API. Two constructors kind of similar to the integer constructors, one where we pass in a double value and one where we can pass in a string and it will get the double value from that string. It has a similar method to get the primitive data type from the object. This one just happens to be called double value, and it returns a double because this is the double class. On the left, we see an example of using the integer class. We are declaring and instantiating an object from the integer class called I1. We are calling the constructor and we are passing in the int literal 35. That 35 will get stored in one of the instance variables of that class. On line 2, we are declaring and initializing an int object called I2. We are going to grab the int value from that instance variable from the object I1 and add 2 to it. That method call of int value, that will evaluate to 35. We're going to add 2 to it, which will be 37. So I2 will be 37. When we print it out later, that's where we get the 37 in our console. On line 3, we are declaring another primitive type int variable called I3. This one we are assigning it the value evaluated by integer dot max value. We saw that max value is an instance variable of that integer class. We saw it was static, so we call it by class name. We say integer dot. We don't call it by object name. We would not say I1 dot max value. That means when we print out I3 later, it will hold the biggest value that an integer can hold. We see a similar situation on the right for the double class. We are declaring and instantiating a double object named D1. We are assigning it the value returned by the constructor when we create a double object, passing in the double literal 3.5. On line 2, we are declaring and initializing a variable of type double named D2. We're assigning it the value of the double value of D1 plus 2. D1.double value evaluates to 3.5. It will get that double value from the instance variable. We will add 2 to it, which will evaluate to 5.5, which will be stored in D2. When we print out D2 later, it will have the value of 5.5. So what is the difference between the primitive data type int and the wrapper class integer? The primitive data type int can only hold a single value. We can put an integer value in it, anywhere from that negative 2 billion number to the positive 2 billion number, while the integer wrapper class can represent an int value, which means it has a member variable that stores an int value. The primitive data type int, again, all it can do is hold a single value. The wrapper class can tell us the minimum integer value. Primitive data type int can only hold a single value. That's the only thing that it can do. The wrapper class integer can tell us the maximum integer value. Primitive data type int, oh, look at that. It only holds a single value, that's it. The wrapper class integer can turn a string into an int. So if we have 32 in quotes, it can get that 32 out of those quotes and turn it into an int that we can do math on. What do you think the last one is for primitive data type int? Am I trying to fool you? No, I'm not. It can only hold a single value. That's all it's good for. The wrapper class integer can be passed into methods that require objects. If we want to pull a method from the string class, we can see the equals method. It requires an object to be passed in. We cannot pass the primitive data type int into this equals method. It specifically needs an object. If we needed to give it a number, we would have to make an object from the integer class to pass it into this method. Okay, let's move on to autoboxing and unboxing. We are still working on that same learning objective. In our code sample, we are declaring and initializing a string variable named s1 to the string literal 32. Then we are declaring and initializing a Boolean variable named b1. We are assigning it the result of calling the equals method on that string object that we just created. And we want to pass in the integer literal 32 into that equals method. We are not allowed to do that because the equals method wants an object only, and a primitive data type is not an object. We are not allowed to pass in the primitive data type of int. However, Java will box up that primitive data type for us. If we left that 32 in code, when Java is performing this task for us and it realizes that that method requires an object, Java will automatically wrap that data type into an integer object for us. This is known as autoboxing, a feature that converts primitive types to their class counterpart. This aligns with our essential knowledge. Autoboxing is the automatic conversion that the Java compiler makes between primitive types and their corresponding object wrapper classes. This includes converting an int to an integer and a double to a double. Also, the Java compiler applies auto unboxing when a primitive value is passed as a parameter to a method that expects an object of the corresponding wrapper class, or when a primitive value is assigned to a variable of the corresponding wrapper class. In this example, we are creating an integer object named I1 and a primitive data type I2. And on line 3, we are trying to add the object plus the primitive type together. We cannot do that because the object is not a value. It is an entire object with methods and instance variables. One of those instance variables does happen to be that integer value of 17 that we want, but the entire object I1 is not 17. So we are asking to add an entire object to the value of 23. When we try to do that addition, Java will automatically unbox the integer value from that class. Unboxing is a feature that converts classes to their primitive type counterpart. This aligns with our essential knowledge. Unboxing is the automatic conversion that the Java compiler makes from the wrapper class to the primitive type. This includes converting an integer to an int and a double to a double. Also, the Java compiler applies unboxing when a wrapper class object is passed as a parameter to a method that expects a value of the corresponding primitive type, and when a wrapper class object is assigned to a variable of the corresponding primitive type. That's it for autoboxing and unboxing. Make sure you rate how you feel on that learning objective. Hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video and keep programming.